Integrated Math 3, this is the answers video for the very first assignment 1.01 called Statistical Inference. It was assigned Monday, January 25th, due Wednesday the 27th for extra credit. I'll continue to give the extra credit until Friday because I'm late in getting this answers video up, okay? Hopefully you were able to do it though based on the PowerPoints. So let's go ahead and get started. So given this data set, calculate the mean. Mean's just a statistics word for an average. And the way you do that is by adding all the numbers up and then dividing by how many numbers you have. So we'll go ahead. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the way you designate that is n equals 10. N is the number of numbers, how many that you have. Okay, so we're going to go ahead and add all these up. For a mean, you do not need to put the numbers in order because they're all going to add up the same way regardless of what order they're in. If you add those up, you get 120. Okay, so the mean, which is designated one of several ways, but we're going to call it mu. That's a Greek letter mu. And it just in statistics means a mean of a sample population. It's going to equal 120 divided by 10, which equals 12. Okay, so that's your answer for that. Okay, the median is the number that is in the middle. It means half of the values in the set are above that number and half are below that number. So we are we're going to go ahead and we need to put the numbers in order for that. So you just have to kind of inspect the numbers. The first one's going to be 7, 8. I don't see any 8s. There's a 9. And by the way, you don't need to add these up. Then 10. Okay, and then we get to 11 right there. And then 12, there's a 12, there's a 12. There's two of them, so you write it twice. And then 13, there is not one. 14, there's two 14s right there and right there. And then 15 right there. And then 16. And always check before you go on after doing this. You might have skipped one. I do it fairly often. I'll miss a number. Okay, so anyway, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's how many numbers we had. So we're going to go with that. All right, so what's half the numbers? Well, there's 10 numbers, so half is 5. So 1, 2, 3, 4, 5. So if I put a little line right in the middle there, and then on the right side, there's 1, 2, 3, 4, 5. So whenever you have an even number of numbers, the middle is going to be in between the 5th number and the 6th number right there. So how do you compute it? You simply add those two numbers together. 12 plus 12 and divide by 2. So 12 plus 12 is 24 divided by 2 is 12. So that's the median right there is 12. I wish they had given in this example not the same numbers, because 12 is not the median because of this one or this one. It's because if you add them together and divide by 2, it's that one right there. It's this 12, okay? So the median is 12. Okay, I'm going to give you a second example that I want you to do with an odd number of numbers. So let's do 1, 3, 5, 7, and 9. This one's a little easier because the median is actually one of these numbers. It's this one right here, this 5, because you have two numbers to the right and two numbers to the left. So if you have an odd number of numbers, here we have n equals 5, then that's going to be the median. It's going to actually be one of the numbers in the set. When it's an even number, it's going to be in between the two middle numbers, halfway in between these two numbers, okay? So this one would be, the median would be 5. for that. Okay, let's keep going. A mode. So a mode is the number that occurs the most times. And it doesn't have to be in the middle. It usually is near the middle, but it doesn't have to be. It can be off to one side. Okay, so again, we'll put the numbers in order. It's the same set, so I'm going to go ahead and just copy what I wrote up there. Okay, so the mode, what number occurs the most times? Well, you actually have two. You have 12, which occurs twice, and you have 14, which occurs twice. So you can write there are two modes. Okay, and this is called bimodal. Bi means two. Modal means modes. Okay, there doesn't have to be two. There could just be one. There could be three. But in this case, we have a bimodal set which has two numbers that appear the most times, 12 and 14. Okay, next up. What is the range of this set? So range is going to be from the lowest number to the highest number. So it's going to be from here to here. Now there's two ways you can express it. You should express the two numbers. So the range is from 7 to 14, 7 to 16 rather. And sometimes it can be expressed by what's the difference. So 16 minus 7 equals 9. So really it should be expressed as the highest and lowest number, but you could also express how far it is between those two numbers. From 7 to 16 is 9. So sometimes that's what somebody wants to know with the range, is how far it is. So either one of those answers, preferably both of those answers, is a good answer. Okay? All right. Okay, now we're being asked for standard deviation, and there is an example of this in the instruction video that you should watch. So what we're going to do is we need to set up some columns to do this. So we're going to take our numbers. You don't have to put them in order, but we're going to do it. And you're going to make 4 columns here. Okay. The first column is going to be the actual data value. We'll call that X. And we have the same numbers, 7, 9. Okay, a little bit of a tight squeeze. If you do this on line paper, of course, it's always safe. You never run out of space. Okay, so here we go. The next thing you do is in the next column, you put the mean, the average of these numbers, and we already computed that. That's 12. So we're going to put 12 here and on every line. So the second column is just the same number for every line. It's 12. Now the third column is going to be the mean, the number minus the mean. It's the difference. And that's called the deviation. Okay, so we'll write that up here. Let's write out what we're doing first. Why are we doing standard deviation? What does it tell us? So I'd like you to write out this definition. Okay, so standard deviation is a measure of how spread out the data is. So I gave the example, if in the video, if I took the numbers 19, 20, and 21 and averaged them, the average would be 20. If I took the numbers 10, 20, and 30 and averaged them, the average would also be 20. But you can see clearly that these numbers are more spread out than these numbers. If someone were to ask you to predict what the next value is going to be, let's say you're taking data and somebody says, what do you think the next value is going to be? I mean, this isn't just for fun. Sometimes you want to be able to predict what's going to happen based on your data. You would be much more comfortable saying, oh, well, I think it's going to be either 19, 20, or 21. Whereas here it could be 10, 11, 12, 13, 14, 15, 16, all the way up to 20, 21, 22, 23, 24, 25, all the way up to 30. It could be a range of 20 there. So this has a range of 20. This has a range of 2. So you'd be much more comfortable predicting the next value. So that's what standard deviation is telling you, is even though you may have the same average, how spread out is the data. Okay, so let's get back to this. So we take the differences here. So 7 minus 12 is negative 5. 9 minus 12 is negative 3. Negative 2. Negative 1. This will be 0. This will be 0. 14 minus 12 is positive 2. Positive 2. 3. And 4. So those are the difference between these two numbers. Finally, you want this, and in the video we use the word for this deviation rather than writing x minus mu, but that's what it is. It's the deviation. So this is x minus mu squared. The reason you do that is you're trying to see how spread out the data is. I think it's a little better without that light on. If all you did was add these numbers up, you know what you'd get every time? You'd get 0. So that doesn't help you because you have some on the negative side, some on the positive side. So by squaring them and then later taking the square root, you get all the numbers to be positive. So you get all these to be positive by squaring them, and then later we're going to take the square root. Okay, so if I do that, negative 5 squared is 25. Negative 3 is positive. Remember, these are all going to be positive because they're squares. Negative 3 squared is 9. 4, 1, 0, 0, 4, 4, 9, 16. Okay, so that's that. Now, what you want to do is add these up. I don't have space down below to do it, but that's called the sum. This is the Greek letter sigma, capital S. And by the way, the symbol for standard deviation is small sigma, and it's this. It's like a sideways 6 maybe, or sideways 9 or something. And that's that's lowercase sigma. This is capital sigma. They mean totally different things. This is the symbol for standard deviation, and that's sometimes abbreviated SD. Again, this is all in the instruction video. This is summation. It's used everywhere, not just in statistics or standard deviation. So it's the sum of, and this time I'm going to use the word deviations squared. And again, this is the deviation right here, and this is the deviation squared. Okay, so this is the sum of these. And when we add those up, what we get is, we get 72. Okay, so that's the sum of all of these. So that's why we made that table, is to get to this number right here. Now again, we have to identify how many numbers we have. We have 10 numbers in all, so n equals 10. So now we're ready for the formula for standard deviation. And the formula for standard deviation is sigma, small sigma, square root, got to be a big square root sign, and it is the sum of the deviation squared over n minus 1. Why it's minus 1? It just is. I won't go into that. You don't have to understand the math or the theory behind that. But it's how many numbers you have, but then you subtract 1 from that. So if we plug that in over here, we get this is this, 72 over 10 is our n minus 1. That equals the square root of 72 over 9, which equals 72 divided by 9 is 8, so that equals the square root of 8. And that again is what the standard deviation is. And sigma equals the square root of 8. You do that on a calculator. So I'll show you on the TI calculator here. It's second, that's second, and then x squared, but up above the x squared is a little square root symbol. So the second activates the light blue symbols that are up above. So second x squared, but it doesn't give me x squared, it gives me square root, because that's the symbol that you see right there, right above x squared. And then I put in the number I'm interested in, 8, and then close the parenthesis. And you go ahead and close parenthesis, it was right there. Okay, and then you hit that and you get 2.8. We'll just go one place after the decimal. So that's the standard deviation. Okay, so let's write out what that means. Our mean is 12. 12. There's our mean right there, is 12. So it means that 68% roughly, so I'm going to put this as means an approximately 68%. And what does it depend on? It depends on two things: how many data values you have, and whether they form a perfect normal distribution. Normal distribution is this guy. I'll try to draw it perfectly. That's that guy, where the mean is right in the middle, so is the median is right in the middle right there. That's a perfect normal distribution. This one probably isn't. It has a 7 way down here on the bottom, but up towards 16 you have 12 and you have 14. So that kind of weights it a little heavier down on this end. It might be a little lopsided on one side. Also, the fewer values you have, the less likely you get exactly 68. If we had 1,000 values and we were taking the average of, we'd get very close to 68%. So it means approximately 68% of the values fall within plus or minus, that symbol means plus or minus, 1 SD, standard deviation, so just learn some of the terminology, of the mean. So what would that be? That would be 12 is our mean, plus 2.8 equals 14.8, and 12 minus 2.8 equals 9.2. So 68%, think of that as roughly 2/3 falls in between these two numbers. So let's check that and see how many do. 7 does not fall between 9.2 and 14.8. 9 does not fall between those. 10 does. 10 is between 9.2 and 14.8. So is 11, 12, 12, 14, 18. 15 does not fall between these two numbers, and 16 does not. So we actually had 6 out of the 10 numbers is 60%. And that's about as close as you can expect to get. I mean, you can expect to sometimes get closer, but that's not a bad number. That kind of verifies this. Again, if we had more numbers, it would get closer and closer to 68%. In this case, 60% of the values fell within plus or minus 1 standard deviation. Okay? All right, so that is standard deviation. I'm going to have you practice a couple of more on some later assignments. Okay, we'll go on to number 6. Let me state very quickly, do not do problem 7. I'm going to do box plots. I do box plots on a later lesson than this one. So if you were wondering what the heck's a box plot because it wasn't in the lecture video, just skip it for now. We'll do it later. It's not hard, it's just I haven't explained it yet. Okay, create a histogram for this data set. All right, histogram, the simplest way to think of what a histogram is it takes your data, your numbers, and puts them into groups. And then you draw a bar graph based on the groups. The simplest way to think of what a histogram is your grades. Okay, if you get between 90 and 100, that's an A. So that would be a bin. Bin just means a grouping. If you get between 80 and 89, that's a B. That's a bin. If you get between 70 and 79, that's a bin. So you put the numbers that fit within that bin together and then draw a bar for them. Now, it doesn't tell you what your bins should be. So you get to choose what you want them to be. I'm going to choose to make them bins of 2 numbers starting with 7. Okay? So that means we're going to have, and ideally whenever you're drawing any kind of graph like this, go ahead and just use a straight edge of some sort. You don't have to measure it precisely. So I'm going to come down here. So I'm going to use 7 and 8 is going to be a bin. 9 and 10 is is going to be a bin. 11 and 12, 13, 14, 15, 16 is going to be a bin. You could have chose bins of 3, 7, 8, 9, 10, 11, 12. You could have even started your bins at 0. 0, 1, 0, 1, 2, 3, 4, 5. You could have done that. But I'm going to start actually with the lowest number here, which is 7. So we're going to put 7 and 8 together. We're going to do groups of 2. That's just the way, just like somebody decided once upon a time an A is 90 to 100, and B is 80 to 89. It could have been different. You could have had that done differently. All right. So I'm going to do about a half a centimeter. Yeah, about a half a centimeter on each one. So I'm just going to put a mark. Each of these, so I'm on the metric side of my ruler. Each of these numbers that you see here, they're a little hard to see, is a centimeter. So a half a centimeter is going to be a bin. A half a centimeter is a bin. And I got one more than I needed. Okay, and then simply how many is on this side? How many numbers are in that? So I'm going to just put 1. It's not what the value of the number is, it's how many. 2, 3, 4, and that's as high as we need to go. Okay, so in bin number 1, you know what? That's just going to be a little hard to read. Let me have a do-over here if you don't mind. I'm going to make each one a centimeter so you can actually write the numbers. So it's this one, this one, this one, 7, 8, 9, 10, 11, 12. That's what I'm marking off here. 13, 14, 15, 16. Okay. Okay, so this is going to be the bin for 7 and 8, for 9 and 10, for those pairs. Okay, so 7 and 8. So we have a 7. We don't have any 8s, so there's only one number that fits in this bin. That's 1. So I'm going to come up here to 1, and I'm going to draw a little bar here. Right there. So that's my 7 and 8, and I really should have a line, an axis along here. Okay, so there's one number in the 7 and 8 bin. How about the 9 and 10? You got a 9, you got a 10, so there's two numbers. There's a 1 9 and 1 10. So I'm just going to come up here a little. Okay, so there's two numbers in the 9 and 10 bin, 1 9 and 1 10. 11, 12. So we have an 11 and a 12 and another 12. So now we have three numbers in the 11, 12 bin. So I'm going to go up to here, up to 3. And come up here. And come across here. And there's 3 numbers right there. Make that even with the 3 right there. There you go. So 3 numbers in that bin. 13, 14. Well, we have a 14 and a 14, but no 13, so there's 2 numbers there, these 2 14s. So we're going to come back up to this level, the 2, like that. Oops, good drop. Right there. And these should all be the same width, you know. I'm not doing it, measuring them precisely. And then the 15 and 16 has these 2 numbers, 15 and 16. So that's also it. And something like that. So that's what it's going to look like, okay? It's how many numbers you have in each of those groups. Just like how many students got an A between 90 and 100. How many students got a B between 80 and 89 and so forth. Okay, so that's how you do. So you get to choose, in case you were wondering, you bin. That's what those groups are called, the bin size. What numbers you wanted to include. They should all be equal intervals. So this is 2 numbers, 2 numbers, 2 numbers, 2 numbers, 2 numbers. That should stay constant, okay? Make the interval, the number of numbers in this case, the same. Okay, so skip 7. That's it. You can turn this in by Friday and still get the extra credit because I was very slow on getting this up. And that's it. We'll see you in class on Wednesday.